Assalamualaikum, we are from Group 18. So this is a short video of our dynamic assignment which was called as High Speed Ride. It was located at Formosa Water Park. So this is the video. As you can see, the boy is sliding down the water slide from point A to point C at the figure 1. For your information, the slide is about 4-story height and the angle of the slide is 45 degrees. Okay, so for the question is, the 60 kg boy in figure 1 slides down the water slides which point A is start from rest. The coefficient of kinetic friction between the boy and slides is mu k equal to 0.2. Given the water slide radius of curvature is rho equal to 2.058 meter. Determine his speed when he reached at B and C. Okay, we will find the VB first. By using principal work and energy, which is this one, we can find the velocity at B. Okay, by using this formula, which is the kinetic energy, 1/2 mv squared. M is the mass, which is 60 kg. VA is 0 because it starts from rest. So here is the answer. For kinetic energy at point B, the mass is 60 kg and VB is the thing that we need to find. So here is the answer with an unknown. This one is the formula of work done by all external and internal force component from A to B. UW, this one, is the work of weight, while UF is the work of friction. UW is the force of weight times with the distance, S. The distance of S is the height of A to B, which is 3. And this is the answer. For UF, the formula is mu k and A times with S. This one has a negative because the friction is going to the different way. The friction is going to this way while the particle going to the other way. So it make it negative. If it's a positive, it will be in the same direction, like this or either like this. Okay. For the distance, which is 5, we can get it from the Pythagoras theorem, which is this one. The value in here is 3 and this one is 4, which is this one 4. To get this part is 3 squared times with 2 together, it will be 5. So here is 5. Then we also can get the total hypotenuse of this part, which is using the same thing, 12 meter squared times with 16 squared, which make it 20. So that's how we get the 5. And this is the answer for it. We are going to find the NA, which is this one. We're going to find it by using summation of Fy. I've already shifted the axis. The axis should be in origin, which is XY. But I already shifted in this way, X prime and Y prime. And A is already in the shifted axis, but not for the W. W is 60 times with 9.81 and the cos 45 adjacent to the 45 degrees, while this one is the friction. 0.2 is the coefficient times with NA equal to 0. Okay, then we can get the NA, which is this one. We apply the principal work and energy. This one is 0. This one is UW plus with UF equal to kinetic TB. Then we get VB 6.8774. So that's it for finding the VB.
Question A, not finished already. After we get the velocity of the point B, then we must find velocity of the boy at point C. We using the same method, which is principal work and energy. This for principal work and energy equation, which is a kinetic energy at point B, initial kinetic energy at point B plus the external work done of particle during the force equal to final kinetic energy of the particle at point C. So, firstly, we calculate the kinetic energy. Kinetic energy formula is 1 over 2 mv square. Firstly, we calculate the initial at point B. We substitute the value 1 over 2 times 60 mass of boy times the value velocity at point B, which is 6.8774 square. Then we will get the answer 1418.959, the answer of initial kinetic at point B. After that, we calculate the initial kinetic at point C. This formula we substitute, but the VC is the value that we want to find, so we did not know. After that, we do the work done that acting to the particle is work of weight and work of friction. Before that, we must know the formula of work done is W equal to F times distance. Work done is amount energy the force give to the object. Okay. The summation work pointed at point B to C is work done by all the force acting on the particle moved from point B to C. Work either can be positive and negative scalar, depend on the direction. Okay, work in positive when same direction and must be parallel. So in this situation, we have two work done is weight and friction. Firstly, we calculate the work of weight. The formula is weight times distance. Firstly, we find the weight 60 times 9.81. Then we calculate the height of the point B to C. The height in the question state the height from B to C is 9 meter. So we get the answer. Okay, why work of weight is in positive? Because it will be weight in downwards. Weight is will in downward direction. Then height, particle motion of the ball also downward. So the distance of the height also downward. So it will be positive. The most important also, force weight must be parallel with distance. So after that, we calculate the work of friction, which is the formula. Firstly, we must find the force of friction, coefficient of friction times with normal force at point B. Then times with displacement the ball travel from B to C S. We get 15 meter. Alright. Firstly, we find and we have two unknown here. work of friction and normal force at point B. So firstly, we must find normal force at point B to get the work of friction. To find the force of friction, we must use coefficient of friction times the normal force at point B. So firstly, to find the normal force at point B, we are given the rho is radius of curvature equal to 2.058. Alright, where we get the value of rho, we get from this picture. This picture, we can see the height of slide is 12 meter. We use the ruler equipment to get the radius of curvature. Then from the measurement of ruler, we make the ratio to get the original of measurement at the radius slide. We use this ratio, so we will get the answer of rho. After we get the rho, you can see the FBD is weight acting to the particle, friction direction opposite to the particle moving, AT is the particle direction moving, AN is the radius of center of curvature, AN is center of curvature, MB is acting on the buoy. After that, alright, where this point B, we can see the shape is curvature, so we use the normal and tangential component. So for the normal tangential component, we use the summation Fn equal to MAN MB minus the F88 D is weight, adjacent with 45 degree, so 488.6 cos 45 degree equal to 60 mass of the buoy. Then AN we did not know, so we must find the AN. AN formula is V square per rho. If we substitute the value of velocity at point B, we get the 6.8774. This value we get from before calculation. Then we divide with rho, we get the answer. Alright, why the AN is negative? Because AN is downward, AN direction downward. We assume the summation Fn equal MAN upward is positive. We assume this positive. So AN downward, it will be negative. It will be negative. We substitute into this formula. Lastly, we will get the answer MB equal to negative 962.767 kilonewton. The answer we get is negative, so our assumption is wrong. The right direction is downward. Alright, why this calculation we did not use the summation FT equal MAT, because I think if we use the summation FT equal MAT, we can use this friction, but we have two unknown, alright, 0.2, I'm try MB equal MAT, so we have two unknown. We didn't, so we use summation Fn equal MAN is more suitable to get the answer. Okay, after we get value answer of normal force at point B, we can find the work of friction. We substitute into the formula work friction. Negative 0.2 is coefficient of friction. This value we get from Google with our research. The water slide material plastic is coefficient friction 0.2. then we times with normal force at point B, then we times with 15, which is displacement boy travel from B to C is 15. Alright, why we get work of friction is negative? Because coefficient of friction direction is right here, coefficient direction is here, then the particle, the boy moving is here, so it different direction will be negative. So from here we will get the negative coefficient friction times with normal force, then times with displacement. We will get the answer work of friction. After that, we substitute, we apply this all answer into the principal work and energy equation. Okay, then we will get the VC answer. After that, we calculate, and lastly we will get the answer of VC equal to 17.9831 M per S.